So just from the operational standpoint, coming here is a useful exercise because we get a sense of what we want to be prepared for in the case of Mars.
An hour into their journey, the crew encounters mountains of gray rock, rubble that was seared by the meteor impact, hurled up into the sky, and then rained back down to Earth. As a result of all the trauma, the rocks are now full of cracks and air spaces. Although you can't see any signs of life on the outside, there might be bacteria or other microbes inside. And the same could be true of rocks near Martian meteor craters.
So how much time we've got left?
It's been an hour and 30 minutes since we left the hab.
Out of our backpacks, we still have 3 hours minus half an hour, 2.5 hours. Minus the 30 minutes for contingency, that's just 2 hours left on our backpacks.
Right.
Okay, so we need to head back because if we were to walk back...
Having enough oxygen at all times to walk back to the spacecraft should vehicles get stuck or break down would be standard procedure on a real Mars mission. Back in the habitat, the gray Devon Island rocks are cut open to see what's inside.
When you slice open the rock and you look at it under the microscope, you see the green microbes actually growing within the rock. And they're growing within the rock so they can protect themselves from the ultraviolet radiation and extreme desiccation. It's like a little microenvironment. And it's that sort of existence in an extreme environment that we're interested in terms of trying to look for life on Mars. Should we be breaking rocks open on Mars and looking for life in the same types of locations that we find it here in the Arctic?
Mars simulation, day 11.
Well, we're the next crew, and we're come from far. From Sri Lanka, from Denmark, from France, from Canada, from the US. This looks like nothing before I've seen.
Certainly not Earth. No Earth I've ever seen.
The new crew, commanded again by Robert Zubrin, will spend the next 10 days in the habitat, more than any other group this season. As they settle in, it quickly becomes clear someone else besides Zubrin is a Mars fanatic.
Here you have the Earth and Mars spinning endlessly through space around the Sun, crossing by each other every 2 years and 2 months, like so.
Hi, I'm Charles Frankel. I come from Paris, France, but I also did my studies in the US, and I'm a geologist by training, and I do science writing as well.
Mars is my favorite planet, after the Earth.
It doesn't say Froggy, it says Frankel. That's great. I'm here because of the love of planetary exploration. I grew up as a kid loving the Apollo flights. I met a lot of the men who walked on the moon. I don't think I will ever make it to Mars, but I'm very excited in preparing it for other people.
You're the commander of the EVA, okay? Which means that you should do most of the talking to Ham.
We will ultimately go to Mars. That's a given. The only question is when.
Okay, the door has been sealed, and we're all three standing now at the foot of the ladder.
Mars beckons us for 2 reasons. It's a planet that has as much land exposed as the Earth, so it's Earth number 2 in a way, and it's close enough really to colonize, and that's not science fiction. It will be science. It will happen.
This is our first time as a crew in a spacesuit on another planet, or so it seems.
It's a very warm experience. Yeah, very hot in here, very humid. It's not very heavy. You can fairly easily move, maybe because of the gravity.
And looking over the landscape is actually breathtaking. We know from aerial photography before landing, quote unquote, that we're on the rim of an impact crater, looking into a very wide depression full of interesting rock formations of all different colors, grays and browns and tans. We are attempting to survey the minerals and the rocks all around the hab to have a sense of the mineralogy of the place, since these are our first steps on the surface.
One of them.
And taking a few samples along the way, which we will analyze back in the hab.
So we've been able to do fun science here. We've been out in the field, we've collected samples,
and it's been kind of a game to, of course, figure out what are we looking at.
None of the crew members are experts in Devon Island geology, so they consult often with colleagues back home, a parallel to what might happen on a real Mars mission.
Dioxide.
I think a crew on Mars would have a lot of interrelation with Earth, because we might not have all the specialists we want on a crew flying to Mars, so we'd have to rely heavily on support from the Earth. And that interaction is very important.
To test this idea of getting support from Earth, we travel a mile back to NASA Base Camp, where a simple experiment has been organized to see how communication might actually work between a Mars crew and home. Pascal Lee and Charles Coquelle are not in the simulation right now, so they're pretending to be scientists on Earth talking with Mars astronauts by a slow, two-way video conference.
Good afternoon, how are you doing? I guess we can't hear you because you are on Mars and we're 20 minutes or so removed from you. But we have a science traverse plan to send up to you.
So this traverse will be a joint geology and biology traverse. We have some microbiology objectives and some rock collecting objectives. Now, if you go on the objective of the experiment was to simulate some people on Earth putting together an EVA plan and then transmitting that to a crew on Mars and have them perform that EVA based on the information sent to them by the crew on Earth.
The main objective of the traverse we would like you guys to carry out is to reach a distant and massive ejecta block.
It's a rock the size of a house, apparently thrown from the crater when the meteor struck.
Thanks, Matthew. That's the tape of the traverse. If you could take us to the habitat.
Drive safe, okay? Thank you, Matthew. We could have sent this message to the crew by radio waves, but we chose to have Matthew Pudlook, this young student who was working with us this summer, carry a tape to the habitat crew with our request. We were simulating this grand time barrier that exists between the Earth and Mars.
The time barrier comes from the distance between Earth and Mars, which varies from 34 to 250 million miles.
Mars is not like the Moon from the standpoint that it is much farther away. When you say hello on the Earth, radio signals will carry your hello at the speed of light to the Moon in 1.5 seconds. Mars, the shortest one-way light time trip is 4 minutes. When Mars is closest to the Earth, it can go all the way up to 20 minutes, and this is the one-way light time trip. This will have a profound impact on how we can stay in touch with people on Mars, how we can help the crew on Mars.
Following on from the fact that it's an ejector block, of course we don't know how shocked the block is. But if it was shocked during the impact event, the cracks may provide a habitat for life. What I would like to do is, if there is life in that rock, is to estimate the biomass that is living on the entire ejector block.
Okay guys, this is it. We hope you have a great EVA and tell us all about it. Good luck.
All right, that's good. Listen, the way we're going to do this, we're going to do a 4-person EVA, and Christine will be Capcom. And we're clear the instructions are to proceed as directly as we can to the site of interest. So we're ready to go and look forward to doing this tomorrow.
The crew heads deep down into the meteor crater, following GPS satellite coordinates sent by Pascal and Charlie.
How close are we to Trinity Lake?
Not sure. We're going to take a reading. So are we right here where these two break off? We have to go almost 2 kilometers that direction. I think that's the rock.
While there wouldn't be a GPS system on Mars, astronauts would have some electronic means of navigating. After an hour-long journey, the crew arrives at their target, and the rock is the size of a small house.
Stand by for GPS coordinates of our primary objective, the large house-sized rock. Over. What we're going to be doing here is we're going to be measuring the size of this